In the center of Rome stands an amphitheater that has captivated the minds of engineers, architects, and historians for centuries. This colossal structure, known as the Colosseum, is not just a monument, but an engineering marvel whose secrets we are still uncovering today. Built in the 1st century AD, it served as an arena for gladiatorial combat, theatrical performances, and even naval battles. But how did the ancient Romans, without modern technology, powerful cranes, or computer calculations, manage to create a structure that has stood for thousands of years? We will talk about the genius of Roman engineers, the materials they used, and the methods that seem incredible even today. We will examine what makes this structure unique and why it is still impossible to reproduce it with the same level of durability and elegance. Watch the video to the end to find out how the Romans built a building that could hold an entire army of spectators and stand for almost 2,000 years. Construction of the Colosseum began in 72 AD on the site of a former artificial lake. This lake was part of Nero's Golden House. Draining it was a difficult task, but Roman engineers managed it by creating a network of drainage channels. But the main challenge lay ahead: how to build a gigantic structure weighing hundreds of thousands of tons on marshy ground. Roman engineers approached this problem with their characteristic meticulousness and pragmatism. They understood that on unstable ground, simple construction would not even support its own weight, let alone the multi-ton loads of stone, concrete, and thousands of spectators. That is why a fundamentally new approach was developed, which proves so effective that it still serves as a model for modern construction on difficult sites. First, a huge trench was dug. It was not just a pit, but a gigantic depression, almost 13 meters deep and over 240 meters in diameter. Thus, the construction site was unimaginably huge, and its preparation required enormous effort. After the trench was dug, the second, equally important phase began: reinforcing the bottom. Oak piles were driven into the ground to create a kind of wooden mesh. These piles, immersed in a thick layer of clay, provided additional stability and served as reinforcement for the future concrete foundation. Once the wooden grid was in place, the trench was filled in. But this was no ordinary concrete. It was a special Roman concrete, which we will discuss later. The Romans used a mixture of lime, water, sand, and volcanic ash, pozzolan. It was this ash that gave the concrete its incredible strength and durability. The pouring was done in layers, and each layer was compacted to avoid voids and ensure maximum density. The result was a monolithic concrete slab which was up to 12 meters thick in some places. This slab became the foundation of the Colosseum. It not only distributed the load evenly, but also insulated the structure from unstable soil, preventing subsidence. This engineering feat allowed the Romans to erect one of the largest buildings in history on a site that seemed completely unsuitable for construction. Modern engineers, analyzing this foundation, have come to the conclusion that the Romans did not simply build, but created a geological foundation that surpassed the natural soil and its qualities. This foundation was designed to withstand not only static loads, but also dynamic vibrations, such as those caused by earthquakes. Such foresight and understanding of the physics of materials and loads are astonishing even today. The construction was so large-scale that a complex logistics network, including special roads and lifting mechanisms, was used to deliver materials to the construction site. All this made the process as efficient as possible and allowed the project to be completed in a surprisingly short time. Can you imagine what would have happened if the builders had not paid proper attention to the foundation? Write in the comments how the Colosseum would look today if it had been built on ordinary soil. One of the main reasons why the Colosseum is so well preserved is Roman concrete, or opus caementitium. It is not just a mixture of cement and aggregates like modern concrete. Its distinctive feature was the use of volcanic ash called pylon. This material was found in the vicinity of Naples and was mixed with lime and water. Unlike ordinary cement, Roman concrete had unique properties. It was very strong and, more importantly, became even stronger over time. Pozzolana reacted with water and lime to form special minerals that made the concrete resistant to water and even sea salt. This property made it possible to build not only amphitheaters, but also aqueducts, port structures, and bridges that have survived to this day. One of the main secrets of the durability of Roman buildings is not only the ingredients themselves, but also the way they were prepared. In addition to pozzolan and lime, Roman engineers used a unique method known as hot mixing. Instead of slaking lime with water before adding it to the mixture, they added unslaked lime directly. This reaction, which took place inside the mixture, released a huge amount of heat. In essence, it was a controlled boiling of the concrete, which created specific mineral formations within it. Lime inclusions. For a long time, these inclusions were considered a sign of poor quality, sloppy work. But as it turned out, they were a key component. These tiny white particles in the concrete performed a unique self-repping function. When microcracks appeared in the material, water seeped through them. It reacted with the lime inclusions to form a calcium-saturated solution. This solution then crystallized and turned into calcium carbonate, effectively filling the cracks and preventing them from spreading further. Thus, Roman concrete was not just an inert material, it was a living, dynamic system that healed itself. This property allowed buildings to withstand not only natural wear and tear, but also natural disasters, including earthquakes, which were common in the Mediterranean. This process continued for centuries, making old buildings even stronger. The Romans built with the understanding that time does not destroy, but strengthens. They created not just structures, but eternal monuments that could withstand any test. This approach is profoundly different from the modern one, where we most often use materials with a guaranteed but limited service life. Our concrete, although extremely durable, does not have the ability to self-repair. It inevitably cracks and deteriorates under the influence of time, moisture, and temperature changes, requiring constant and costly maintenance. Roman concrete, on the other hand, used these influences as part of its strength. Seawater, which is a corrosive enemy of modern concrete, was a source of vitality for Roman concrete. In port structures, it penetrated deep into the concrete, promoting the growth of rare minerals that made the structure even more resistant to destruction. The philosophy behind Roman concrete was much deeper than just the choice of materials. It was based on patience and long-term vision. The Romans thought not in decades, but in centuries and even millennia, investing not only strength, but also wisdom in their creations. They understood that great things are not built in a day. This was construction for the ages. Their structures, such as the Pantheon, with its huge dome cast from a single piece of concrete, or the aqueducts that still supply water to some areas of Rome, are testament to this approach. They showed that it is possible to create not just utilitarian objects, but works of art and engineering that will outlive their creators and serve future generations. But what if we applied this principle not only to construction, but also to our own lives, laying a foundation that will only grow stronger over time? This reflection leads us to the next question. What can be built on such a solid foundation? Let's discuss this further. The original structure of the Colosseum, consisting of arches and vaults, was the pinnacle of ancient engineering, combining aesthetics and incredible functionality. The exterior facade of the amphitheater is a striking example of how the Romans used arch spans, not only to distribute weight, but also to organize the flow of people. 3 tiers of arches, each supporting its own weight in the one above it, created a light and airy appearance that concealed the massiveness of the structure. On the first tier, the arches served as entrances through which spectators could quickly and orderly reach their seats. This system was so well thought out that it could accommodate more than 50,000 people and evacuate them in just 15 to 20 minutes. A key element in this system was the keystone, a wedge-shaped stone, the central stone at the top of the arch. It did not simply complete the structure, it was the element that took all the load and redistributed it to the sides supports. Without this keystone, the arch would simply collapse. This simple but ingenious detail allowed the Romans to build arches of enormous size, which we see not only in the Colosseum, but also in numerous aqueducts and bridges throughout the empire.